let me talk about a new hypothesis testing problem. We have a fiberglass tire that we're testing, and we think that the lifespan will be at least 40,000 miles. We have a sample of 12 tires that we're testing, and the question is the claim correct? Now we'll start setting up this problem as before, that the null hypothesis will be that the mean is equal to 40,000 miles, while the alternative hypothesis will be that the manufacturer is overstating how good these tires are, and so that the mean is less than 40,000 miles. We'll also set the value of alpha to be equal to 5%. Okay, now we're going to compute the test statistic. However, we notice a couple of things here. The z-test will not work for this problem. For starters, we don't have a big sample. We only have 12 tires. Also, the population standard deviation is not given. And so, unless somehow magically the data follow the normal distribution, which almost never happens in practice, we will have the z-test does not apply. Now we're going to try to turn the crank as before. So we'll figure out the average of the data. So 3,283.33. So that's the average of the data. We can also figure out the standard deviation of the data, which works out to be 2,731.91. So we can use those numbers to compute the test statistic, x bar minus mu, and ideally you'd want to have sigma divided by the square root of n. That's what we did before with the z-test. However, that will be impossible for this problem because sigma is unknown. Now this makes sense in real life, that it's not realistic that the mean is known. However, somehow magically you know the standard deviation sigma. So we're going to get rid of sigma and replace that with the sample standard deviation of s. By making this substitution, we will call this test statistic t. Obviously, this looks an awful lot like the test statistic for the z distribution, except I have a sample standard deviation in the denominator as opposed to the population standard deviation. So under the null hypothesis, this would be 37,283.33 minus the hypothesized mean of 40,000 divided by the value of s, 2731.91, divided by the square root of n, which is 12. Okay, so let's do the computation down here. T is equal to, in this case, it'll be this number minus 40,000 divided by this number over the square root of 12. So negative 3.44447. Okay, so now how do we tell if that is to whether or not to retain or reject the null hypothesis? Let me put that number here, just so I record it. Okay. To tell whether or not to retain or reject the null hypothesis, there are two ways to do it. The first way to do the problem is by computing the p-value. So I find the area under the curve. Now the curve is now no longer going to be the normal distribution. It's going to look something similar to a normal distribution, but it's actually going to be a t distribution with 11 degrees of freedom. 11 because n was 12. The number of degrees of freedom will always be n minus 1. So then I find my mark here, negative 3.444773, and I need to figure out the area to the left of that mark. Okay, now how do I do that? In Excel 2010, the command goes like this: equals t dot dist, and you see the notation there that it returns the left-tailed student t's distribution, and I have this number with 11 degrees of freedom, and it is cumulative for true. So that returns the area to the left of that mark. So t dot dist kind of works like norm s dist. It returns the area to the left, and so that would be the p-value 0.002739. So that's Excel 2010. Excel 2007, if we're using that, the command's a little bit different. The command is tdist. And the argument looks a little kind of the same. You see there's three arguments. It goes x, degrees of freedom, and then tails, one or two tails. So here's the t value, 11 degrees of freedom, and then it's one tail. So that would be the command in Excel 2007, except for one little detail. What I've got here is wrong. If I hit enter, it returns an error. Now the reason it returns an error is because this first number here in Excel 2007 must be positive. Excel 2010, it's perfectly okay for the first number to be negative. However, in Excel 2007, you must have the first number be positive. So this will be negative G3, so I get negative G3, the net effect would be positive 3.44778. And then I get the same answer that I had before, which is 0.002739. So what got returned here in Excel 2010 is the area to the right of positive 3.444773, which is the same as the area to the left of negative 3.444773, because of the symmetry of the curve. So those are the two commands in Excel 2010 and Excel 2007. Later on, I'll show you how to do that calculation on the TI-83 calculator. So using this number that we just got, we have that the p-value is equal to 0.00274 roughly. And so clearly that's less than alpha, and so I will choose to reject the null hypothesis. So that's one way of doing the problem. Let me move this up. That's one way of doing the problem. The second way of doing the problem is by using the critical value. So let me do this in blue. So I have my t distribution again with 11 degrees of freedom. That's a lousy picture. Try it again. T distribution with 11 degrees of freedom. And let me figure out the mark so that the area over here is equal to alpha, which is 5%. Okay, now how do I do this in Excel? In Excel 2010, the command is t.inv. Now notice there's a couple of options for t.inv. You can use the left tail or else the two-tailed critical value. In our case, we want the left-tailed critical value. Probability is 0.05 with 11 degrees of freedom. And so the critical value works out to be negative 1.79588. So that's the critical value, and I'll mark that in my picture here that this is at negative 1.79588. Now, if you're stuck with Excel 2007, this is going to be very confusing, but let me just tell you the way it is. This is no sugarcoating this because it's very confusing. The command in Excel 2007 is tinv without the dot. And you notice the comment is that it is available for backward compatibility. And this returns a two-sided inverse. Two-sided inverse. So that means that if I type this in, that's going to be incorrect because it will assume that the area in both tails combines to be 0.05. And so I get the incorrect answer. To get the correct answer, or at least to get almost the correct answer, I need to take that 0.05 and double it. So if 5% of the area lies to the left, then by symmetry there's another 5% that lies to the right. 5 and 5 gives me 10%, 0.10. And so when I hit enter here, I do get the correct answer, except of course I want the negative answer as opposed to the positive answer. Okay, so if you're using Excel 2007, that's the command that you need to use, and you need to mentally remember that you have to double the area, because the only choice in Excel 2007 is to input a two-sided critical value. Also, the positive number gets returned, the negative value never gets returned. Okay, so that's Excel 2007. I will mention this on the TI calculator. It is impossible to get, sorry, on the TI-83 at least, it is impossible to do a critical value. I believe on the TI-84s and more advanced, it's possible. On the TI-83 at least, it is not possible to do the critical value, and so you'll need to use the table in the book. And in a separate video, I'll talk about how to use the table in the book to get the critical value. Okay, so that's Excel 2007. So we have the critical values here. And so as always, that is our demarcation point. I'll mark that in green. On this side, we reject the null hypothesis. And on this side, we retain the null hypothesis. In our case, negative 3.44 falls over here, and so the decision is to reject the null hypothesis. So in words, our conclusion is we reject the null hypothesis. It does not appear that does not appear that the tires last 40,000 miles. Finally, let me talk about how to do this calculation on the TI calculator. So let me bring that onto the screen. So it's possible to do the p-value in the calculator. The command is second distribution, and I go to tcdf, and then I input the left endpoint. The left endpoint would be negative 10 to the 99, so essentially negative infinity. And then the right endpoint, which we worked out to be negative 3.444773. And then the third argument will be the number of degrees of freedom, which is 11. So this kind of works like the normal CDF command, except I have to put in the third argument for the number of degrees of freedom. And then hitting enter, I should get basically the same answer that I had before, 0.002739. And so the p-value can be computed with the TI-83 or TI-83 plus. TI-84, as I understand it, will also do critical values, but the TI-83 cannot. In a separate video, as I mentioned, I'll talk about how to use the table in the book to find the critical value from the table if you have a TI-83 and we need to figure out the critical value.